So today we're going to be doing 513, which is going to be polynomial applications. Now on this lesson, I will give you all some help on the homework because the homework can be a little challenging without some guidance. And then I also want to just remind you of some upcoming dates. So 513 is going to be polynomial applications. So this one says the graph of Acme Corporation's revenue in thousands of dollars based on the price of the company's charge for a widget is displayed here. So what price should the Acme Corporation set for the widgets to maximize the revenue? Well, revenue is the y-axis here, right? And the x-axis represents the price of the widgets. And all of these prices are in thousands of dollars, all right? So when they say, well, not the widget prices, but the revenue prices, this is like 500,000, 600,000, and so on. So right here is where we reach our maximum revenue, right? Does everyone see why that point represents maximum revenue? So what is the price of the widget at that point? It's the x-coordinate of that point, which is 11.22, right, if we round it. Because when we do dollars, we always want 2 decimal places because that's how we do money. So if you charge $11.22 for the widget, that's going to maximize your revenue. Does everyone see how that applies? Now, why is it bad to sell the widget for $4.80? Good, we don't make any revenue. Any idea why that would be? If you're selling it for cheaper, wouldn't you make more because more people would buy it? Good, yeah, so they may be spending a lot of money to make the product, so they're not making as much money back if they're selling it for cheaper. Now, why is it bad when they sell it for $15.30? Too expensive, no one wants to buy it, right? So usually the value falls somewhere in the middle. That's going to be the optimal selling value, right? So setting the price of a widget below what cost would result, or sorry, below what amount would result in the company losing money? If you sell them for $4.80, right? Does that make sense why that is? Okay. And then it says true or false, charging $7 for a widget would generate $500,000 for Acme Corporation. So $7 is somewhere around here, right? So if we go up and we see what point that matches around 250,000. So is that true or false?
False.
False. It doesn't reach 500,000. All right, so far, does it make sense? You need to go to the nurse?
I'm perfectly fine.
Okay. So this question says, the rare yellow-bellied thrasher's population is declining on a small island. So this is a type of bird. And the population of the species over time can be represented by P of t is equal to negative t to the fourth plus 27t squared plus 324, where time is in years. In the context of the problem, what does 324 represent? Anyone know? Any guesses?
Like the population when it started.
Good. So the initial population. So that's how many birds there were when they started the study. And then is the population increasing or decreasing over time? Good. And I know that because of the negative sign in front of the t, as well as the fact they tell me it's a declining population. So now they want to know how long before the bird becomes extinct. The bird becomes extinct when its population reaches what amount?
0.
Good. So what we're going to do is we're going to replace P with 0. And now we got to factor this. So I'm going to start by factoring out a negative 1. And then I'm going to factor this into two binomials. What are factors of negative 324 that add up to negative 27? I'll just tell you, you know, as long as you understand that's what I'm doing. Negative 36 and positive 9. So the reason I was able to factor this way is because this is a 420 trinomial. Do you remember these? Yeah, we learned about them not too long ago. Was it yesterday? I think it was a few days ago, but yeah, so you factor it like normal, but instead of t, you put t squared or x squared. And then what would I then do with these? I would set them equal to, I'd set them all equal to 0, yeah. Okay. And then I just solve. What's going to happen to the first one?
Yes.
It's rejected. Square root. So how many results did we get?
4.
Good. We have time is equal to 6, time is equal to negative 6, time is equal to 3i, and time is equal to negative 3i. So which one of these units of time makes the most sense for time in years?
6.
Good. What's the problem with all the other answers?
That one's negative. You can't have negative time. You can't have imaginary time. You say
Good. All of these get rejected, and we call them
extraneous.
extraneous. Good. So does everyone understand why we yielded 4 solutions, but only one of them, was actually useful to us? Does that make sense? Okay. So basically, in 6 years, they theorize that this bird will go extinct based on the data in math. That describes the situation. Okay? All right. Next question. So it says here, founded in 2020, the Acme Corporation's revenue in thousands of dollars is modeled by the polynomial r of t is equal to t to the 4th minus 4t cubed plus 2t squared plus 10t minus 200, where t is the number of years after the business started. What does negative 200 represent in the context of this problem, and what would the projected revenue be in 2030?
$200 is dead.
You are on the right track, but the revenue is represented in thousands of dollars. So we're not just negative $200. We're actually
$200,000 is dead.
good. We're actually negative $200,000 debt. So that means that the company is starting in $200,000 of debt before they even open their doors. Does that make sense to everyone how we inferred that? Okay. So now we want to figure out their projected revenue in 2030. And it says here that T represents the number of years after the business started. The business started in, so how many years later will it be in 2030? So we're going to plug in what for T? 10. And we also learned, I think it was yesterday or the day before yesterday, that you could also have done synthetic division with the 10 instead of plugging it in, right? And if you simplify all of this, I'll just tell you, you get 61,000, and then we have to add how many zeros to the end if it's in thousands? 3 zeros. So the company actually ended up with a revenue of, in 2030, 6.1 million. So was it worth them going into debt? Yeah. So going into debt won't always leave you in debt. Sometimes it pays off. Now this is just their projected revenue. Any of you guys ever watch that show Shark Tank?
I did.
You know how they'll be like, my projected revenue for this year, these are the kind of equations they use to come up with that. And the issue with projected revenue is it can be biased. Because if I made my own projected revenue, if I did my own research for my projected revenue, what could be some potential issues with that?
You just manipulate the numbers.
So if I'm trying to sell you to invest in my company, would I be the best person to be doing the math behind these formulas?
Probably not.
Why not?
Because you can make it sound more than it is.
Yeah. So while math is like a very concrete science, the issue is you can still use math to make things like, you can use it to your advantage to make things look better than they possibly could, right? So yeah, for example, like this is only projected revenue. This doesn't mean that that will be the revenue in 2030. You know what I'm saying? It's just a projection. So there is a difference there. Okay? All right. So the next question says, consider a polynomial function p of x is equal to x to the fourth minus 3x cubed plus ax squared minus 7x plus 14, where a is an unknown real number. If x minus 2 is a factor of this polynomial, state the value of a. And they give you a hint, application of factor theorem will help. Application of factor theorem states that if you divide a polynomial by its factor, the result of the remainder will have to be what? Somebody said it quietly, I think. 0. So we're going to do synthetic. I think you all like synthetic better than long division, right?
And it's not close.
It's not what?
Close. Yeah, it's
Oh.
not, yeah, this is better, and it's not close.
Oh, I got you. So what's going to go on the outside here?
Negative. Oh, positive 2.
Good. And on the inside?
1, negative 3, 1, negative 7, and 14.
Almost. So our coefficient is actually a. And that's okay. So if there's one thing that you can learn in math class is when you have a letter instead of a number, you're just going to go as planned, okay? We just still treat it like a number. It's okay. Don't be frightened by it. So let's go ahead and proceed. So we're going to bring down the 1, multiply, combine, multiply. A minus 2, that's just a minus 2. I can't do anything with it. Now I'm going to multiply 2 times a minus 2, which is just 2a minus 4, right? And then here I can just combine like terms. What's 2a minus 4 minus 7? 2a minus 11, right? And then I will multiply this times this, which gives me 4a minus 22. And then once again I have some like terms here that I can combine, and that's going to give me 4a minus 8. Now we mentioned earlier that the remainder should have been what? 0. Is it possible that there is an a value that exists that would make this remainder 0?
Yes.
Yeah, how could I find it mathematically?
4 times 2.
Yeah, you found it in your head, but you basically did that math by technically setting it equal to 0. So a is equal to 2. So what that means is, had you been given that polynomial with a 2 instead of an a, and you did that division, your remainder would have been
0.
0. So I really like these problems. They're types of problems I like to give for extra credit because I feel like they're really like, they're not like super difficult, but they still like require you to kind of think outside the box. So this is the end of the notes, but I'm feeling generous today and I want to give you some hints on your homework questions. So I'm going to go through each one of them with you and kind of like talk you through what I would do if it were me. Okay. So I'm not going to be going through these questions like entirely like I did with the notes, but I'm just going to be like talking you through the process of them. So it says Polly's Pasta and Pizza Supply sells wholesale goods to local restaurants. The revenue in dollars from the kitchen supplies and food product sales over a 1-year period is represented as the function K and function F, respectively, where T represents the month number. So when they say T represents the month number, when I plug in 1, I'm referring to what month?
January.
Good. So yeah, January, then February, then March. You get the idea between what the letters represent with the months. So they say state the revenue that Polly made from kitchen supplies in March. So basically what you're going to be doing here is this represents kitchen supplies and this represents food products. So if you want to do March, you're going to plug in what value for T here? Good. So you'd be plugging in 3 into K of T, right? Now you're going to notice that this problem's going to get old really fast with all that plugging in. So we have this other tool called Desmos, right? Anybody know what we could do in Desmos to figure this out?
Type the equation in.
Yeah, we could put in both equations, right? So theoretically, if I had Desmos open, which I will in a second. Okay, so we got Desmos. And if I type both of these equations in, I have K of T. Now here's the one issue with Desmos. Desmos doesn't take T as a variable, so you have to change all of your T's to X's, okay? So it's not any different, but you just flip them around to X's. Just be careful of that because Desmos says, oh, T's not a variable. So yeah, you gotta go with their rules. It's their website, right? So we got X, and then we got plus this. So this formula right here represents the kitchen supplies, right? So if I take this and I go to table, what am I going to be typing in for X here? 3. Good. So that would come out to be 3,497. And then you can use this process for any of the months that they're asking for. So what I suggest is you're going to get to a problem where they want you to compare months. So I go in and put in all the months. You know what I mean? And then you're able to easily compare them. Alright, so that's how you're going to go about doing number 1. And you're welcome to borrow a computer if you return it. So, next problem is number 2. So this question here would also help to use Desmos. So it says, the volume of air during a 5-second respiratory cycle can be modeled by where V is the volume in liters and T is the time in seconds. So basically as time goes on, like the volume fills up, right? So state the volume of the air in the lung 4 seconds into the respiratory cycle. So here you could plug in T, for 4 for T, or you can put it in Desmos and then put in the table 4 and it will give you that value. State when the volume of the air in the lungs is the greatest. Here you'd be looking for the what? The maximum. And then state how much air is in the lungs at this time. Basically right here, so V represents volume in liters and T represents state when. So here you're actually finding the max. This is going to be the x coordinate of the max. And this one's going to be the what?
Y coordinate.
The y coordinate. So this one's telling you when there's that much, the most volume, and then what the actual most volume is. T versus V. Okay. This question here, I'm actually going to give you the function because I find it actually to be a pretty difficult problem without it. So it says Universal has entrusted you to design, first of all, they're going to entrust you to design a roller coaster. Alright, fair enough. So they've entrusted you to design the first 10 seconds of the next roller coaster attraction. The criteria for the coaster includes a starting height of 200 feet, a dive below the ground level 3 seconds into the ride, and a return to the ground level 2 seconds later, and another dive beneath the ground 10 seconds into the ride. State the polynomial function that models the first 10 seconds of the ride. Here it is. And if you were to multiply it out, it would also be equal to this. And then from there you can graph it in Desmos and evaluate the rest of the problem. So the last problem was really tripping up my last class, so I just want to kind of help you set it up. It says you want to create an open top box from a flat piece of cardboard with the dimensions 32 by 20. To do this, you need to cut the same size square out of each corner and then fold the flaps up to form a box. Determine the size of the square that would allow you to optimize the volume of the box, and then state what the optimized volume would be. So if you think about a piece of paper, if you cut 4 equal corners out of a piece of paper, you could then fold up the sides to make an open top box, right? Do you get what I'm saying? So you like cut it out and then you fold it up on each side and you have like a very shallow little box, okay? So that's what they're talking about. So if you think about it flattened out, let's talk about what the paper is going to look like at that point. So here's the piece of paper originally, and you're going to have to figure out how to cut this paper to make this setup, okay? So you're creating it from a cardboard that has, this side is 32, and this side is what? 20. Now you have to cut an equal box out of each of these. So here you're going to cut out a box. You're going to cut out a box here, here, and here. Now keep in mind these boxes are all supposed to be the same size. It's just hard to draw them that way. So these boxes are perfect squares, and we're going to call the dimensions of that box x. So like each side is represented by the letter x. X by x by x. We don't know how big they are. We just know that it's called x. So everyone understand why they're all the same size. So now we have to figure out the new dimensions of the sides. So basically we're trying to figure out the length of this piece right here. So we know the whole thing is 20 and we're subtracting away what? It's 20 minus this x, right? And then minus this x. So 20 minus x is just 20 minus 2x. So you see how we subtracted away those two side pieces to get this piece right here. Now same idea goes for this piece. We want to find the length of this piece. So that's going to be 32 minus what? 2x for each of those box lengths. And then let's talk about what the height of the box is going to be. So think about it realistically. If we fold that side up, the height of that side is going to be x, right? Because it's going to be the length of that side that you fold up. So your last dimension, here's your first dimension, second dimension. So this is your, we'll say, your length or your width. This is your length. And your height is just regular x, because that's how tall the box is. We don't know yet. So they want to figure out, you optimize the volume. So you're going to multiply, find the volume, and put it in Desmos and look for the maximum. Alright, so that's what I'll give you, and you have a little bit of time to work on it.